Hello. We've already finished section 4.4, but I did add a couple of extra problems just to give you more exposure to some of the little intricacies that come up as we're working through these problems where we have a non-homogeneous part. So we're just going to do two more examples for this video, but they will take up a little bit of time. All right, we're going to follow the same process that we have before. I am going to shorten some of how I write this to give you kind of examples of proper ways to present your work, kind of the bare minimum of what you should be showing, that sort of thing. So typically when I'm writing up a problem like this, I know right away it's non-homogeneous, and so I need to break it into parts. I need to find my y sub c, and I need to find my y sub p, okay? So y sub c will still be tucked up in a little corner. We're solving the problem y double prime minus 8y prime plus 20y is equal to 0 when we try to find y sub c, and we let y equal e to the mx, and then substitute it and its derivatives into the differential equation. That gives us m squared e to the mx minus 8m e to the mx plus 20 e to the mx is equal to 0. And then we factor out the e to the mx. That leaves behind m squared minus 8 plus 20, and that's all equal to 0. The quadratic will factor, and remember e to the mx is never 0. So we end up with factoring of, looks like m minus 10 times m plus 2. That's all equal to 0. So finally we have roots of m is 10 and m is minus 2. And of course these are the multipliers in our exponent for our exponential solutions. We have that y sub c will be c1 e to the 10x plus c2 e to the minus 2x. Okay, so that's the work for y sub c. We can make it go fairly quickly. Y sub p now is based on g of x. And remember, g of x is going to be this whole thing, 100x squared minus 26x e to the x. Now, looking at this, I do see that there are two parts, and I want to show you what I mean when I say that you can treat your guess as a sum of guesses, okay? So I'm looking at g of x, and I see that there's a quadratic, and then in addition, we also have a linear term times an exponential, okay? And so I'm going to say that y sub p1 is going to be my guess for the quadratic portion. Y sub p1 should be the quadratic family in standard form, which is ax squared plus bx plus c. Okay? When I compare this to y sub c, it looks like there are no repetitions. So this is a good guess. I'm going to leave it as is, okay? Then I'm going to set up y sub p2, and y sub p2 should be based on the term that has a linear times an exponential, and so I'm going to choose to write this as ex plus f, that's my linear, times my exponential function e to the x. And when I compare to y sub c, what I see is I have no repetitions again. So these are both good guesses, okay? So now I want to do the work for y sub p1. Okay, I have split my y sub p up into two pieces, and so that means I'm going to go through this process 2 times in order to find all my unknowns, a, b, c, e, and f. For y sub p1, we are going to sub y sub p1 equals ax squared plus bx plus c, y sub p2 prime, which is 2ax plus b, and y sub p, I accidentally said p sub 2 in that one, y sub p1 double prime, which is equal to 2a, and we're going to sub these into y double prime minus 8y prime plus 20y equals 100x squared. I'm not going to be looking at the minus 26x e to the x part because that will be y sub p2 that takes care of that one. Okay, so this is kind of the little subtlety that isn't blatantly obvious when you decide to take your particular solution and split it into two parts, going after your undetermined coefficients. Okay, so when we substitute everything in, y double prime is 2a minus 8y prime. I'm going to go ahead and distribute the 8 and the minus, so I get minus 16ax minus 8b, and then plus 20y will give me plus 20ax squared plus 20bx plus 20c, and this all adds to 100x squared. So I need to organize my terms. I'm going to rewrite things so I have 20ax squared, and then for my x terms, it looks like I have plus, in parentheses, minus 16a plus 20b, all times x. Okay, so I just combine those like terms. And then for my constants, I have plus 2a minus 8b plus 20c is equal to 100x squared plus 0x plus 0, where I wrote those two additional terms just so that we can very clearly equate coefficients. So when I say equate coefficients, I'm looking at the x squared terms and seeing the coefficients are 20a and 100. That means my first equation should be 20a is 100, which means a is 5. Okay, that's nice and quick. Then I'm looking at my x terms. Minus 16a plus 20b has got to be 0. So that's my second equation. Minus 16a plus 20b is 0. I know that a is 5, so I'll go ahead and substitute that in. 5 times negative 16 is negative 80 plus 20b, that's 0. 20b is 80 and b is 4. Okay, last but not least is the constant part. The 2a minus 8b plus 20c needs to add to 0. So that's my third equation. 2a minus 8b plus 20c equals 0. I know a is 5, so I have 2 times 5 minus 8, and b is going to be 4, plus 20c is 0. So I have 10 minus 32, that's a negative 22, plus 20c is 0. So c is going to be 22 over 20, or 11/10. And what that means is that y sub p1 is, it's ax squared plus bx plus c, but now we know the values. 5x squared plus 4x plus 11 over 20. Nope, sorry, 11 over 10. Okay, so that's all the work for y sub p1. Now we need to do y sub p2, so I'm going to shrink this up a little bit just to make sure I have enough room. And then we'll get started on y sub p2. All right, with y sub p2, we had ex plus f times e to the x. So we're going to sub y sub p2 equals ex plus f times e to the x. And then we need to calculate y sub p2 prime, which is going to be, okay, this is going to be a little bit weird. I'm dealing with ex plus f as one term and e to the x is another, or factors, I should say. And so the derivative of the first is just going to be e times the e to the x plus the derivative of the second is e to the x. So I have ex plus f times e to the x. And then I'm going to combine like terms, I'm going to factor in e to the x out of everything. And what that leaves me with is this is equal to ex plus e plus f times e to the x. Okay, And then I also need y sub p2 double prime. So the derivative of the first is e times the second, e to the x, plus the first, ex plus e plus f times e to the x. And then I factor out the e to the x, and I have that this is ex plus 2e plus f times e to the x. So we're going to sub all of those into y double prime minus 8y prime plus 20y equals the negative 26x e to the x. Okay, so now we're dealing with that second part of the non-homogeneous term. All right, so we substitute everything in. Y double prime, we've got ex plus 2e plus f e to the x minus 8. So this is a little weird how I do this. I go ahead and I distribute the minus 8 into the parentheses where I have ex plus e plus f, and I just write a plus outside. So when I distribute a minus 8, the inside of the parentheses becomes minus 8ex minus 8e minus 8f, all times e to the x. Then I have plus 20y, and again, I do that same thing. I distribute the 20 into the linear terms. I get plus 20ex plus 20f, all times e to the x. And this should be equal to negative 26x e to the x. Okay, now I need to factor e to the x out of all three of these terms and combine the like e's, ex's, e's, and f's, okay? Very, very carefully. So I'm going to go through and highlight my e to the, or my e times x's. Okay, and then whatever's left over, let's see, we've got e's in there. So we've got 2e minus 8e, and that's it. And then everything else is f's. Okay, let's do this. So I have 1e minus 8e, that's going to be a negative 7e, plus 20e, that's a 13ex. I have 2e minus 8e, that's minus 6e. I have f minus 8f, that's minus 7f, plus 20f is 13f. All times e to the x is equal to negative 26x e to the x. Okay, last thing I'm going to do is I'm going to rewrite one more time. I have 13ex times e to the x plus, in parentheses, negative 6e plus 13f times e to the x equals negative 26x e to the x plus 0 e to the x. This is so I can identify those undetermined coefficients that need to be found. So we have terms that have x e to the x in them, and the coefficients are 13e on the left and negative 26 on the right. Those have to be equal, which means e is negative 2. Then we have the coefficients minus 6e plus 13f on the left, and that must equal to 0 on the right. Because we know e is equal to negative 2, we can substitute that in. So we get 12 plus 13f is 0, or f is negative 12 over 13. Okay, and so what this means is that y sub p2 is ex plus f, so e is negative 2x, plus f is negative 12 over 13, all times e to the x. Okay, so what was the benefit of this? Well, by doing the work individually for y sub p1 and y sub p2, I was able to just focus on a few things at once. Now, if you can imagine just for a moment that we dealt with all of y sub p, all of y sub p would be ax squared plus bx plus c plus ex plus f times e to the x. We'd have to find y prime, y double prime, and we'd have to substitute them all in at once and keep track of a lot of terms all at once. For myself, This sort of organization makes a big difference, both in my sanity and in my ability to get the correct answer. So I share it with you and hope that it helps you. But our last step is to get the general solution. So remember, the general solution is y equals y sub c plus y sub p. Our y sub c was c1 e to the 10x plus c2 e to the minus 2x. Our y sub p1 is going to be plus 5x squared plus 4x plus 11 over 10. And our y sub p2 gives us plus, in parentheses, negative 2x minus 12 over 13, all of that times e to the x. And that is the full solution to that differential equation. So just a little bit bigger and a little bit more than the previous problems in the last video. Let's try one more where we've got some initial values that we have to deal with. In addition, dealing with the sine-cosine family, because that one can be a bit lengthy and tedious. And so I want to show you some organization tricks that have helped me in the past. In this problem, we're solving the differential equation y double prime minus 4y equals x sine of 2x. We're given initial values y of 0 equals 0 and y prime of 0 is equal to 0. We need to remember that we apply these only to the general solution, not to y sub c by itself, not to y sub p. Okay, it is to the general solution. So we'll start off with, let's find y sub c. Okay, when we're finding y sub c, we're solving y double prime minus 4y equals 0. We let y equal e to the mx. We're going to keep this all in a box. When we substitute y and its derivatives in, we get m squared e to the mx minus 4 e to the mx equals 0. The e to the mx factors out and leaves behind an m squared minus 4. M squared minus 4 becomes m plus 2, m minus 2. And so our solutions are going to be negative 2 and m is equal to 2. So y sub c will be c1 e to the minus 2x plus c2 e to the 2x. Just highlight that so we don't forget about it. All right, y sub p. So based on g of x equals x sine of 2x, it looks like we have a linear times, well, remember, sine doesn't hang out alone. It comes with cosine, right? So we have a linear times sine of 2x, and then plus a linear times cosine of 2x. And remember, they each want to have their own linear. So let's do that. Y sub p will be ax plus b times sine of 2x plus cx plus d times cosine of 2x. You need to be super duper careful with c's when you're doing this, because the c that's with x, if that c is going to be with a cosine, it can get you in trouble. So maybe, just to be on the safe side, I'm going to skip over c, and let's just do dx plus e. Okay? Just try to share little tricks that have helped me through the years to make sure that I don't make mistakes that are silly, that can be avoided. Okay? All right. So if this is y sub p, let's compare it to y sub c. There are no repeats with y sub c, so this is a good guess. And there's a lot to it. So the very first thing we need to do is find y sub p prime, and then we have to find y sub p double prime. Okay? So y sub p prime is going to equal, we have two product rules, and I'm going to do a similar trick to what I did before with the exponentials, where I combine all the things that have sines and all the things that have cosines when I'm done. Okay? So y sub p prime, derivative of the first is a times the second, that's the sine of 2x, plus, well, the derivative of sine of 2x is 2 cosine of 2x. So I get plus 2 times ax plus b cosine of 2x, plus the next group, we have a product rule again. The derivative of the first is d times cosine of 2x. And then the derivative of cosine of 2x is a minus 2 sine of 2x. So I get a minus 2 times dx plus e times sine of 2x. Okay, I am paying attention very closely to the two signs that I have in the equation, as well as the two things that have cosine in them. And I'm going to combine like terms. So for the cosine stuff, I have a 2ax plus a 2b plus a d, all of that times cosine of 2x, plus for my sine stuff, I have a minus 2dx minus 2e plus a, all times cosine of 2x. Nope, sorry, sine of 2x. Okay, so that's y sub p prime simplified. Okay, y sub p double prime, similar process. I have product rules again, and so the derivative of the first is 2a times the cosine of 2x. And then the derivative of cosine of 2x is a minus 2 sine of 2x. So I'll get a minus 2 times 2ax plus 2b plus d times sine of 2x. In the next group, the derivative of the first is minus 2d sine of 2x. And then the derivative of sine of 2x is 2 cosine, so I get plus 2 times negative 2dx minus 2e plus a, all times cosine of 2x. Okay, again, I need to organize. I have my cosine term, and I have my two sine terms. Okay, so my cosine terms, when I gather everything together, I have a minus 4 dx, I have a minus 4e, I have plus 2a and another plus 2a, so it's a plus 4a, all times cosine of 2x, plus. Now here, for sine, I have a minus 4ax, I have a minus 4b, I have a minus 2d and another minus 2d, so it's a minus 4d, all times sine of 2x. Okay, it seems silly that I did all of that factoring. However, when we have to combine three things that have all these terms in them, you want things written as factored as possible so that you can very clearly see what's like and what's not like. It makes a difference. Okay, oops. So now, in the next step, we are going to substitute y sub p and its derivatives into y double prime minus 4y equals x sine of 2x. Okay, so let's see what that looks like. Y double prime minus 4y equals, well, y double prime has the minus 4dx minus 4e plus 4a, all times cosine of 2x, plus, in parentheses, minus 4ax minus 4b minus 4d, all times sine of 2x. And then I'm going to do a similar thing to what I did in a previous problem, which is where when I write the minus 4y. I'm going to write it in the line below so that I have things lined up really well. And I'm going to distribute the minus 4. Okay? So the cosine of 2x term needs to be written first, and distributing the 4 to it gives me a minus 4 dx minus 4e times cosine of 2x, and then plus, and my sine of 2x term is up here, and again distribute the minus 4, so we get a minus 4ax minus 4b all times sine of 2x. And I need to combine those, okay? So for the cosine stuff, I have a minus 4 dx and a minus 4 dx. That's minus 8 dx minus 8e plus 4a all times cosine of 2x. Plus, for my sine terms, I have a minus 8ax minus 8b minus 4d times sine of 2x. And all of this is supposed to equal, what is it? X sine of 2x. Okay, so here's what I'm seeing. I have my cosine terms and my sine terms. My cosine terms have different factors. There's the x factors, and then there are the constant factors, like the multipliers. Like I could distribute the cosine of 2x to join with the x term, and then to separately join with the constant terms. I choose to keep them separate, but I examine them together, okay? So now what I'm seeing is on the left-hand side, I have x cosine of 2x's, I have constant cosine of 2x's, I have x sine of 2x's, and I have constant sine of 2x's, and it's equal to just an x sine of 2x. So let me see what I can come up with from here. My first equation is minus 8 dx cosine of 2x. There are no x cosine of 2x's on the right, so this is equal to 0, x cosine of 2x. I'm kind of showing a step I don't usually write out. I usually just go straight to equating the coefficients, and I don't write out the functional part, but I'm writing it out this time, because then it's very clear, hopefully, to you what I'm doing. Well, this means that minus 8d is equal to 0, or in other words, d is 0. My second equation comes from looking at the constant, the minus 8e plus 4a times cosine of 2x is equal to 0 cosine of 2x. Okay, and that gives me another equation, minus 8e plus 4a is 0. I can't really do anything with that right now, so I'm going to get my third and fourth equations. My third equation is the x sine of 2x's. I have minus 8a x sine of 2x on the left. That is equal to x sine of 2x on the right, which means minus 8a is 1, or in other words, a is negative 1 over 8. In 4, I get the equation for the constants. I have minus 8b minus 4d times sine of 2x equals 0 sine of 2x, which means minus 8b minus 4d is 0. Now I have a couple of substitutions that I can put in. D is 0. That can be substituted into equation 4. A is a negative 1/8. That can be substituted into equation 2. So I'll work with equation 2 first. Substituting a negative 1/8 in for a means minus 8e is negative 4 over 8, plus negative 4 over 8 is going to be a minus 1/2, and that's equal to 0. And then this means that minus 8e is a positive 1/2, or e is a negative 1 over 16. When I plug in D is 0, I get minus 8B is 0, so that B is also 0. And so now I have all of my values. And I can go ahead and form my y sub p. So remember y sub p, it was ax plus b sine of 2x. So let's deal with that. Ax plus b, only a gives us anything. So y sub p is a negative 1/8 x sine of 2x plus. And then we get dx plus e times cosine of 2x. D was 0, e was negative 1/16. So I get minus 1/16 cosine of 2x. And that's it for y sub p. Okay? It's a lot of work. In my mind, organization is probably the most important tool that you can use in this class, period. But it becomes blatantly clear when you start working with the method of undetermined coefficients, because if you're not organized, it's too easy to get lost in all the work. One more step here. We need our general solution, and then we have to use the initial values. The general solution is y equals y sub c. Y sub c was, that's right, c1 e to the minus 2x plus c2 e to the 2x. And then we have our y sub p minus 1/8 x sine of 2x minus 1/16 cosine of 2x. I'm also going to need y prime because I need to apply my initial conditions. Y prime will equal minus 2c1 e to the minus 2x plus 2c2 e to the 2x minus 1/8 sine of 2x, and then plus 1/4 x cosine of 2x, just using a product rule, and x sine of 2x. And then we get a plus 1/8 sine of 2x. All right, y of 0 is 0 is the first one. So that means 0 equals c1 plus c2, 1/8 x, that's going to go to 0. Cosine of 0 is 1, so just minus 1/16. So we get c1 plus c2 is 1/16. Y prime of 0 is 0. When we plug in 0 there, we get minus 2c1 plus 2c2. All the signs are going to go to 0. And the x, cosine of 2x, that's also going to go to 0. So we just get minus 2c1 plus 2c2 is 0. And when I move the 2c1 over there, I get c2 equals c1. Okay, and so when I put these two together, if c1 is, or c2 is equal to c1, then I get c1 plus c1 is 1/16, which means 2c1 is 1/16. c1, which is the same as c2, will be 1/32. Okay? And so now, more formally, we can write, not sure where to write it, okay? General solution is now y equals c1, which is 1/32, e to the minus 2x, plus 1/32 e to the 2x, minus 1/8 x sine of 2x, minus 1/16 cosine of 2x. And that right there is our final solution to this problem. All right, so I hope it helped to see a couple of more intense problems. Sorry to make 2 videos for it, but I figured that it would be best that you can get started just having seen the first couple of examples, but you're going to get to some problems in the homework where they're a bit more difficult, and so hopefully these help with that. As always, if you have any questions at all, please feel free to reach out.